So far, we've learned how to use numbers, write some arithmetic expressions, calculate other numbers doing that. But you may have noticed that we can't actually save the results of anything we do. All we can do is print it. Well, we need to fix that, okay? In order to actually write any kind of program, we need to be able to actually save the results and use them again and do something with them, right? So in this video, we're going to talk about variables and assignment. Variables are a way to save your values so that you can use them later. And assignment is how you assign a value to a variable, all right? So let's look at how these work. Right, one way to think about variables is to think of them as names that allow us to save values and refer to them later. Okay, so in order for that to work, we have to actually assign some value to that name. So here's a simple program that has two assignment statements in it. You can see the equal operator is assignment. So what's going on here is I have two statements, one that is assigning the result of the expression 12 plus 1 to the variable baker's dozen, the other that is assigning the result of the expression, well, it's just a number, but that's still an expression, the number 93 to the variable temperature. Let's run this program. Nothing happened. Well, you probably could have predicted that, right, if you thought about it for a minute. There's no print here. So I'm not asking anything to be printed. Rather, I'm just saving values. I'm saving the result of that 12 plus 1, which was 13, okay, in the variable baker's dozen. I now have it available to me, but I didn't actually use it for anything, okay? And I want to point out that these expressions on the right-hand side of the equal sign can be arbitrarily complicated. You can write whatever arithmetic expressions or other expressions that evaluate to values you want. Okay, it doesn't have to be limited to just a number or just 12 plus 1. We can use, the more complicated compound expressions we've learned about, for instance. Now let's actually print these out. Let's do something with the values that we've saved. Okay, so if I uncomment those lines and run the program, now it starts printing things out. Now, the first thing I want you to realize is that print, I can have any number of things inside of my print as I want, as long as I separate them with commas. And each comma inserts a space into the output. So I printed the two variables, temperature and baker's dozen. I have a comma in between it, so we get out the result, 93 space 13 in the console. Think about this for a minute. Hopefully this makes sense. It did not print the word temperature or the words baker's dozen, right? Instead, it printed the values of those variables, okay? So baker's dozen is now 13, and so when I ask it to be printed, the number 13 shows up. Baker's dozen is a name inside my program. Okay, so baker's dozen is now a variable, temperature is now a variable. I can use these variables in arithmetic expressions. I don't just have to use numbers. So if you look at the next line here where I'm printing out the temperature in Celsius, okay, if I said 93 was the temperature in Fahrenheit, well, if I subtract 2, multiply by 5, divide by 9, I get the value of 33.8888. Right, that is the equivalent temperature in Celsius given 93 degrees Fahrenheit. Okay, so notice again, I used the word temperature in the program. That is the name of a variable. It does not get used as the word temperature. Rather, it evaluates to the value that it currently holds. It was assigned the value 93 up here above, and so it's 93 in this arithmetic expression. So it does 93 minus 32, gets back 61, multiply by 5, divide by 9, and that's where we get the 33.8888. Okay. I can convert it to a float because it is an integer, right? It's the integer 93. I can print out my Fahrenheit temperature as 93.0, right, by converting it to a float, right? So variables, once you've assigned a value to them, you can just use them as if they were values inside of your other expressions. Okay, and this is extremely powerful. You can see that I didn't have to keep retyping the number 93. I can just use the variable temperature and it has the value 93. Now I can also change this program, right? If I just go up here, say, well, actually, that's not the temperature. The temperature is now 78, and you'll see everything changes. Okay, when it prints out 78. The conversion to Celsius now gives me 25.5. When I print it out as a floating point number, I get 78.0. Now, the values of variables are not permanent. You can reassign them. Now, I just changed the value of temperature from 93 to 78, but it still only was assigned one value. It's just, I changed the program and gave it a different value. You can also actually change the value of the variable while your program is operating, okay? And now let's look at what happens here. By changing the value of the variable temperature to be 26, okay, so I use the equal operator again to assign 26 to the variable temperature. It's 26 at the end, but it's still 78 up above, right? When we first print it up here, it still prints 78. When we print it again down here, it's 26, okay? So the variable holds the value you give it until you change it. And so when you use it in expressions, it uses the value that it currently has, and then you change it, and whatever expressions happen after the change, they get the new value, all right? So I can change the value of a variable, and I can do this as many times as I'd like. Now, let's look at the code here down at the bottom. I want to point out that my expressions can have more than one variable in them, right? There's nothing stopping me from using as many variables as I would like and creating compound expressions that mix variables and numbers, right? So if we look down at the bottom here, I am trying to make my conversion to Celsius look a little bit nicer, right? It's the temperature minus the offset times a multiplier. Well, I need to know what the offset and the multiplier are, so I assign 32 to the offset and 5.0 divided by 9.0 to the multiplier, and now I can convert from Fahrenheit temperature to Celsius, and then finally I can then print out the value that we're done. And so we see that 26 degrees Fahrenheit is negative 3.333 Celsius, right? So I can use variables anywhere that I would have used a number before, or any expression before, quite frankly, okay? So I can write an arbitrary expression, and the resulting value I can assign to a variable, and then I can use the variable in other expressions, okay? And I can build these things up to arbitrary complexity. Now, I want to make one final point here. The names of your variables matter, okay? You should choose names that make sense. You should not just be using the letter Z as a variable name. Python might let you do this, but it's a bad idea, all right? And in this class, we're going to enforce, some style guidelines where we require you to use variable names that are at least 3 letters, okay? Now, just being at least 3 letters is not good enough, right? If you name your variable ABC, I have no idea what it means. You want to use something that is meaningful in the program, like the word temperature. Okay, that tells me that the value that is being held by this variable is a temperature. Okay, so please get in the habit right from the start of choosing meaningful variable names that allow you and anyone else reading your program to understand what you're storing in that variable, right? If you do that, variables become an incredibly powerful tool in our programs where they allow us to save these values. Okay, we can, by looking at the variable name, have an understanding of what values we're saving, and then we can use them over and over and over again in other expressions. And this helps make our programs more reusable. It helps to make them more understandable as well.